Hello everybody and welcome to another Blender tutorial. This time we will try to recreate this effect on our denser. As you can see, this is not just a simple particle system because those balls actually react to each other and they are not intersecting one another because they are run with the physics simulation of rigid bodies. So let's try to create it with the Blender. And little disclaimer, prepare yourself that it will be heavy for your computer. Blender isn't exactly prepared for this kind of solver. I shouldn't say it, but especially this effect will be probably better to create it with something like Houdini or Cinema 4D that have specialist settings for physics of spheres that are trying to stay on some place. Okay, with this behind us, we will definitely use Blender in this tutorial. Of course we will. So let's jump right to it. And we will need animation nodes, definitely. Without it, it will not work, this method. And we will need this file that you can see with this tensor. This file you can download in the description, of course, as in the previous tutorial. There is just this alpha surface of this robot, alpha joints, and on the second layer is armature with this motion capture animation from mixamo.com, also link in the description. So we have everything that we need. So let's prepare our file for our effect. First of all, we will not use these alpha joints at all, so we can just delete them. So select them, delete these alpha joints. And second of all, we will use physics simulations and maybe dynamic paint or something that will be simulated on the fly. So for us to be able to actually loop this animation after the render, we need two loops to have two loops of this animation to have right now. And as in the previous tutorial, we will just select this armature, split this window, go to the NLA editor. Here you can see this action of dancing, and we need to repeat it twice. So in this panel, find action clip, and here is repeat, and set it to 2. So now we have two loops of this same action. We need to set the end of the animation to 150, of course, and we are prepared. Okay, what we need to do, of course, create some sphere with rigid body simulation. So let's jump to some another layer and create sphere. It doesn't matter what sphere, UV sphere, icosphere. I like the topology of rounded cube, so I will use rounded cube. Let's shade it smooth and add some rigid body physics to it. So go to the physics panel, of course, name it somehow, like ball, add to rigid body, active, dynamic, not animated. Mass could be like 0.1. For this purpose, shape, of course, sphere. This is good. Just the damping. You can see that the motion on the end of the hands and on the end of the legs is pretty rapid, pretty fast, and changing pretty rapidly. So we don't want this sphere to just flying around. So we will increase this transition damping to something like 0.9. It should work as expected, or I believe this is what I set for this particular animation. Okay, let's try to run the animation, and it falls down, of course. It's expected, and we want to hold this sphere in this place, in the place where the sphere was created, but not with animation. We want to hold this sphere here with forces, and I didn't find really a way how to apply a force on this rigid body, not in the Blender game engine, but just in this rigid body simulation. So we have to use rigid body constraints. But constraints works only on 2 rigid body objects. So we need second rigid body object. Let's add, for example, cube. That's pretty simple object. So why not use cube? And it could be our anchor. And this anchor will have to be rigid body also, not active but passive. But even if it's passive, it will be animated, so it's recalculated every frame, each frame. Collisions, we really don't care. It could be box, but definitely different collision group. So the anchors will not collide with other balls. We definitely don't want that. And on the anchor, we place our rigid body constraint. Okay, it will not be fixed, it will be generic spring. Enable it, disable collisions. Okay, first object is of course our anchor, and second is ball. Okay, it should work. Let's see what will happen, and we can see that nothing happens. The ball still falls down, and that's because we need to activate these springs down there. And it should already work, and when we move our ball, our anchor, the ball tries to move with it. So this works pretty nice, but we need a much larger force because of the fast movement on the dancer, so like 64, and again the damping, because we don't want the vibration, the overshooting of this sphere. So 0.9 again. Okay, everything we can change later if the animation is not what we expect. So we will jump here and change everything right here. Okay, so we have prepared our little physics simulation for everything, and we need to somehow instantiate it or duplicate it on some points inside of this geometry, of this dancer. And if we want points inside the geometry, what we do, we create particle system. Okay, go to particle system, new. How many particles we need? I think like 360. 360 was in the final animation. You can experiment with it also, but prepare it's really heavy for a computer to calculate 360 anchors, 360 rigid body springs, constraints, and 360 rigid body spheres at once with the animation nodes running in the background. So be prepared. Okay, we want all the points already from start. So start and end will be 0, lifetime something high, so we don't have to worry about if the particle is live or dead. The particle will be always live in the length of our animation. Emit from volume, so the points are inside. Random, use modifier stack, because the particles are generated after the deformation of the armature. And velocity, we don't care. Physics, no. So when the character is moving, the particles stays in the same place. It's really not that visible from this from the recording, but you have to believe me, the particles are still in the same place relatively to the geometry. And it's pretty much all. We don't have to worry about anything else in the particle system. We just need to duplicate our balls and anchors to all these points, and we will use animation nodes for it. So jump to the node editor. Well, I want to see inside of this character, so display wire. Okay, I see inside. animation nodes here, create new node 3, and we don't need it to run always, just when something is changed. Well, first thing first, we need the particle system. So where it is? Particles from object. Okay, we need where is our particles? Where are our particles? They are in alpha surface. So let's select the alpha surface. We have our particles, but we need where they are to get their locations. So again, particles, particle list info. And now we connect this, and here we have all the locations. Okay, so we need to place, first of all, we need to duplicate all anchors as many times as the particles are there. So 360, but we want to calculate it automatically in the node 3. So here, object instancer, and we want instances of anchor, and how many times it will be duplicated is the length of this location list. So how many particles there is, that many anchors will be created. Okay, and now we need to place all these objects to all these locations, and for this we need loop that will run through all of these anchors. So just put there some layout, so we need we will see what is our working node 3 and some helpful little node 3s here. One of them will be subprogram loop that will place everything where it should be, so some placer, and it will need two iterators. First is of course objects, so object list. It takes all these objects and place them to the locations, so vectors, so list of all the vectors. And how it will be placed? With object transforms output, we will change the location of the object. Object is this, location is here, so this should work. And let's just use our helpful loop right here. Subprogram placer, let's place it right here, and we will take all these objects and place them to all these locations. Something happened, but you can see the cubes are really big for now. We can change them in this loop also, so change the scale of the object as well, and we will scale them by some parameter. It will be just simple float. Let's name it scale so we know what we are doing, and connect this scale to the vector scale. It will automatically create a node that will change just one value to vector of the same values. Okay, let's see where we are working. We have the scale set to 0, so the cubes aren't visible at all. But if we change it a little bit, you can see we are changing the scale of all cubes at once. This scale is irrelevant, it's just for the visual perspective of what we are doing. Also, these cubes shouldn't be visible in the renderer, so let's add another parameter to this loop that will hide them in the renderer. It will be just bool, so boolean function, just true or false. Renderer or hide in renderer could be this value, and where it is, object visibility output, and of course it's the same object. I can put it right here, and we want to hide it in render, so let's connect this, and if we set this to true, you can see here animation nodes, all these instances are hidden. If we set it to false, or are visible in the render. So we want to hide them in the renderer, so these cubes will not be visible. And what else? We have our cubes, but you can see if you select some of these anchors, they are still yellowish, orange, and they are not green. That's because they are not in the group that is actually affected by the physics simulation. We need to add them to this group after we copy everything. And to have all these physics settings and physics for the physics simulation, we need a full copy of these objects. So you can see the physics settings are here right now. Everything is same as the anchor that we created in the in this 6th layer, but they are still not in the right group. And because we want a different group for the anchors and different group for the balls, I will create it with another loop and not here in this loop that we have already created. So let's create another loop. This will be just grouping that will add the objects to the group. The iterator will be again objects, so object list, and 2 parameters because we have 2 groups. So object group and object group again. First will be like group 01 and group 02. I should learn how to write group 02, and all this loop will do is just where it is group operations. It will take the object and add it to the first group, and it will take the object again and add it to the second group. And that's all for this loop. So let's add it here. Subprograms grouping. I hope it makes sense, at least a little bit. It will take all these objects that are created and it will add them to rigid body world. So now they are affected by the physics simulation. Now you can see they are green. And for the anchors, they will be also in the rigid body constraints, so the constraints will work properly. Okay. Now we just need to do the same thing for the spheres, for the balls. So I will just duplicate this instancer, not with the anchor, but with the ball. The number of instances will be same, so this length will be plugged here as well. The placing will be same, so I will duplicate this. So take all these balls, place them to all these locations, and not hide them in render. Also the scale could be bigger, like 0.06. Why not? And we can randomize the scale somehow. So let's jump to this loop. When you want to find it in this node editor, just select loop and press the tab key, tabulator. And here we see the loop. And we want to change this scale randomly for each object. So we can find number where it is. Randomize here. Randomize. We need a different seed for each object. So we take index of these objects and plug it here. And the value will be from something to 1. Let's add a new parameter. Like randomness. Why? Yes, parameter is float, of course, and the float will be named randomness. Okay, and this randomness I want to put there some value, but if it's 0, I want nothing will happen to this scale. So I actually have to add a 1 to it. where it is, math at 1. So I will take my value, add a 1 to it, plug it as a minimum. So when I have 0, this math will create number 1, and the random number will be from 1 to 1. So the random number will just be always 1, and nothing will happen because I will multiply this scale with the random number. Okay, but if the randomness will be bigger than 0, then the range of the random number will be also bigger than 0, and it will be randomly scaled. You can see the effect here with the spheres. If I change the randomness to the higher values or lower values, you can see that spheres are random. I will set it to minus 0.9. This could be good. Well, let's see after the simulation. Maybe we will tweak it a little bit. And for the simulation to work, we need again to change the grouping, or not change, to add the groups. So for all the spheres, but not the rigid body constraint, just the rigid body world. Okay, that should work. It looks pretty much done, that everything should work right now, but you probably, some of you know that it won't work, with one simple reason. If you select one of the anchors, one of the cubes, if I am lucky enough to actually select one, and go to the physics settings, you can see that in the rigid body constraint, the object 1 and object 2 are still anchor and ball. It's not anchor 106 and ball whatever this is, ball 106. So we need to anchor this anchor and this ball to be inside of these fields for objects. And we will do it in the animation nodes again with another loop. So right here, why not create another loop that will take two sets of objects. So one iterator, object list, this will be balls, another object list, this will be anchors, and it will change on the anchors. We need to find these properties. So let's find them. Object attribute output. So on this anchor we need to find the object 1. If you hover your cursor over it, on the bottom you can see BPY data objects anchor 106 rigid body constraint object 1, and that's exactly what we need. And we can have it just by right clicking and copy data path, and here I can just go Ctrl V and I have the rigid body constraint object 1, and I can set it to whatever value, and object 1 should be the anchor itself. Let's try it. And we need the object 2 set of also, so let's duplicate this. Object 2 should be just object 2. Let's make sure. Ball rigid body constraint object 2. This is exactly the same. It's on the anchor still, but the value will not be the anchor, but it will be the ball. Okay, this is all for this loop. Let's try to use it. Subprogram. Let's name it somehow. It's not just my loop. It's constraining. Oh, why not? Let's go subprograms, constraining, and we need list of balls. It's here. List of anchors. It's here. And you can see that anchor is anchor 106, ball 106. If I try different cube, anchor 206, ball 206. So everything is connected as it should be. Let's hide the alpha surface. We don't need that for our simulation. Let's save it, of course. And you can try to run the animation, but from my experience, it just simply doesn't work, or it's too slow, even in this number of spheres. So much better, or I found that it's pretty good to, for now, turn off rigid body, and let's bake the animation nodes to the objects, to the animation itself. Here in the overview, you have bake to keyframes. So let's try that. Bake to keyframes. This shouldn't take too long, and it will put keyframes to all the anchors and all the balls. But the balls are still in the place where they are intersecting with each other. But the anchors are already animated, so we can uncheck the auto execution for the animation nodes. Check the rigid body world and bake the rigid body simulation. Let's see, bake all dynamics. It shouldn't take too long. Also, I don't really know why it's so slow when you run it in the same time. Okay, we don't need 250 frames. We need just 150. And select all. And here in the Physics tab, bake to keyframes. Bake to keyframes from 1 to 150. Okay. This will take a while too, but since everything is baked, it shouldn't be that bad. So let's wait. Okay, it wasn't that bad. And let's try to see what we created. And it looks kind of like it worked. Let's see it from the 76th frame. So it loops correctly. And something weird happens in the bottom, but whatever, it's not that bad. If you want to tweak some setting, for example, you want bigger spheres or anything, you have to get rid of the animation. Or, well, you actually don't have to. Just go to the first frame, activate again the animation nodes, change something like the scale of the spheres. They are now bigger, and free all bakes, get rid of the rigid body world, and same steps. Bake to keyframes again. Okay, turn off the animation nodes, turn on the rigid body world, and rebake the rigid bodies. Oh damn, I didn't lower it to 150, so we have to wait for 250 frames. Okay, it's baked. Let's bake it to keyframes again. Okay, and set the start back to 76, and let's see what we created. Well, it probably looks even better, so I will keep it like this. And let's jump to the rendering part. We will need just a camera and something very simple to set up. Let's see, like this. We where it's our world setting. Again, the simplest you can think of. Open some HDR environment like this one. Why not? Put it here. Converter, math, multiply twice. Non-color data. Let's see how it looks on the render. Well, very bright. Mesh plane for the ground. Just something. Ground could be, as always, dielectric. Something dark, but rough. And on the balls itself, it's nice to have somehow random material, but again, nothing really complicated. You can make some of them glass, some of them wood. You can put them on fire or whatever, some of them emission. I will just put it here, dielectric material, and randomize the color a little bit. So input object info, random to the color, and put it through the color ramp. Constant, so I have just few colors like black, red, and white. It's what I used in this video. And you are pretty much set up for everything. Nice effect you can achieve also with the color hue saturation and put the value above 1. It looks like the light passes through the objects, but it's actually just that the objects are reflecting more light than it's falling to them. And we are well over half an hour, so I would end it right here. The rendering is just experimenting with what works for you. Definitely don't forget to add motion blur, but all these things are already baked to the animation. In the dope sheet you can see on each frame is all these things recorded, the scale, location, everything. So there is nothing that should be problem. The ripple effect on the ground could be maybe a bonus lesson. It's if you look at the previous tutorial for the pinpoints effect, it's the same thing. The dynamic paint on the floor is the canvas. The balls are brushes, and they are painting waves. So I would wrap it up. I thank you definitely for watching. I hope you find it kind of useful, maybe interesting or whatever. Let me know in the comments what you think, or if you have some suggestions for whatever. And till the next time, bye.